I'm George Danezis from the Programming Principles and Tools group that also includes some of us who work on security and privacy here at Microsoft Research in Cambridge. So in the last few months, basically, we have been working on privacy for smart metering. Smart metering is an attempt to modernize the electricity infrastructure. So instead of having someone coming around and by hand taking a meter reading every 3 months, or you having to basically report to your utility company how much energy is being consumed in your home, new meters will be automatically beaming to your utility how much electricity is being consumed in your home for up to half-hour intervals. So this is great. It will allow basically our infrastructure to accommodate the new kind of consumption that electric vehicles will bring, as well as allow basically utilities to manage production more efficiently, saving a lot of money and saving the environment. But some people are concerned about the privacy implications that these new meters bring with them. In particular, if your utility company knows how much energy is being consumed every half an hour, they will be able to infer things about your private life, such as when you're asleep, when you're at home, when you're having a shower, when you're having a microwave meal, for example. So our attempt is to try to achieve all the benefits of smart metering, but while at the same time shielding basically customers from any potential privacy intrusion. We have a few technologies to achieve this, but what I will be demonstrating today here is a specific technology that allows utility companies to find out how much consumption of electricity is going on in a particular neighborhood as an aggregate, as a total, without ever finding out how much electricity any particular household is using. This is an important problem because, for example, electricity companies would like to know exactly how much their customers are consuming every half hour in order to draft contracts with producers to match that without actually having any wastage. It is also very useful in order to find out in real time if there is a blackout or a brownout in any particular area in the country. So there is a considerable interest in being able to get these aggregates without being able to find out how much any particular household is consuming. So what this shows here in the demo is a setting where there is an energy supplier, and for the sake of my argument, we have 3 particular mock meters that will be grouped together to provide these aggregate measurements of consumption, and will be simulating households consuming energy at different times of the day. So our protocols for privacy-friendly smart metering rely on the energy suppliers, first of all, initializing all these meters. When a meter is initialized, a secret key is created within the meter but never communicated to the energy supplier, and this key is used to keep effectively the meter reading secret. Then the energy supplier groups meters together, so these are the kind of 3 meters that from now on will be in a group and will be used to get aggregate readings from these 3 meters. And setting up the groups involves basically the energy supplier sending out to the meters the cryptographic keys of all the other meters. These are the public keys, therefore again no secrets, allowing the supplier to find out the electricity consumption are known. And finally, when the meters start recording consumption, as we can see every few seconds here, the consumption is not reported in clear, so the red values are never actually read out by the energy supplier. Instead, the meters are encrypting them in a very special way that we have invented here. And this special way means that no information about the specific meter readings is leaked, but when on the supplier side the meter readings are added up together, their total comes out in clear. So it is effectively a specific encryption scheme that has been designed for this setting that allows the supplier to do this operation of aggregation without ever leaking any information. So this protocol is demonstrated here in a kind of mock example, but we have also implemented it on real meters with partners. And it is quite efficient. In particular, the protocol runs very fast, which means that the current meters that are being deployed can run it without any problems. and the communication required from the meters to the energy supplier are minimal, meaning that they're exactly the same as the communication happening today. So we can deploy the solution to solve this very real problem that the industry is looking for a solution for without effectively burdening the infrastructure anymore.